we will do a quick introduction to R. For those of you who have never used R before, that should cover pretty much 80% of what you need for the class. If you don't have R installed in your computer, you have to install it first. And the easiest way is just to go to Google, and then I'm gonna type R. And in my case, I use Mac, so I'm gonna type R Mac. If you use Windows machine, you can type R Windows. And the first result from Google will be the correct one. So you click on it, and then somewhere here you'll see this file that you need to download and install. So once you download and install R file, you should be able to use R. But there's another convenient tool that I prefer to use on top of the R, which is called RStudio. RStudio gives me a convenient environment to work with R. And to install RStudio, again, I'm gonna go to Google. I'm gonna type RStudio Mac. And again, first result from Google is the one I need. Download the RStudio IDE. IDE is Integrated Development Environment. And I just use free version, which does everything I need. I never experienced anything I need from the paid version, so I'm just gonna click download. Download again here. And now I can install RStudio. Once you install RStudio, you should be able to open it. This is how RStudio looks like. So RStudio window will be separated into 4 parts. And the way it is separated can be controlled in the preferences. If I go to RStudio preferences, and then I click on the pane layout, I can say which pane to be located at which quadrant. So in my case, I have source, which is R script. It's going to be on the upper left corner. Then console is basically output from the R commands, is going to be on the bottom left. And then on the top right, I'm going to have plots and my help window. And on the bottom, I have bottom right, I have the rest of the windows, which shows me the history of my commands, the files that are available in the folder, and a lot of those things that I actually rarely use. So I rarely use this specific pane. So you can control how pane appear in the R window. You can also control the fonts and the colors. So I use the Monaco font, and I use Monaco theme. Theme controls the combination of colors and fonts. So the default one, actually don't remember what's default one, but you can click on it and you can see a little preview of how so default is this one, TextMate. So default one is TextMate. You have black text on the white background. So I prefer colored text on the black background. So I use Monaco, but you can choose whatever theme you want. And let's see how to use those panes. So again, the console pane here on the bottom left in my case, I can just type commands here. So I can say 3 plus 5 here. It will print me the result. Or I can generate a plot here. Plot. And the plot will be shown on the upper right corner in my case. Or I can request a help for the plot command, so by just typing help plot, and again the help will be shown on the top right corner of the RStudio. Okay, so that's pretty much all you need to know about RStudio. It's pretty straightforward to use. And now we'll give you a quick introduction to the R language itself and a few of the commands that you will need for the class. Let's go back to Safari and let's look at the presentation. So first thing, of course, R is a high-level programming language, but don't be scared away by the programming language term. It's very intuitive and very straightforward to use. You can think of R as Excel on steroids, and once you get used to using R, it's very unlikely you're gonna go back to Excel unless somebody forces you to. So basic things, you can do basic arithmetic operations. So 20 power 2 plus 36, R will calculate for 36. You can use parentheses to define the order of the operations. So you do the addition first, and then you divide by 3. And then you can do what is called logical operations. So you can, for example, compare two numbers. So you can ask R if 10 less than 5, and R will tell you false. Or you can ask if result of this operation 10 minus 5 is equal to 5, and R will tell you true. So this is called the logical operation, and the result of the logical operation is either true or false, or 0 or 1, whatever you prefer. Okay, but in most of the cases when we deal with data, we have to deal with sequences of numbers rather than single numbers, and the sequence of number is called a vector. So let's look how vectors look like. So we define a vector A here, and this vector has 3 elements, 2, 7, and 8. And the C command just stands for concatenate. So here we say, essentially what this command says, generate a vector with entries 2, 7, and 8. So 3 elements in the vector. And now we can do operations with this vector. So one of the frequently used one is to collect sum of all the elements in an R just sum command, similar as in Excel, and it will give us 17. So 2 plus 8 is 10, plus 7, 17. And then we can say sum of A divided by 3, so it will give us an average, which is 5.7. Or instead of just saying this, we can use the mean function, which will actually calculate the average in the same way, also will give us 5.7. Often when we try to make a decision under uncertainty, so when some random variables are involved, we use this tool which is called simulation. Simulation is simply a way of generating random numbers. And the simplest random number generator is this R binomial function. We're going to simulate 30 coin flips using this function. So R binomial, it's actually, that's what it is. It simulates those coin flips. And we say, okay, we want to simulate 30 experiments, n equals to 30. Size equals to 1 means in each experiment we flip coin only once. And probability of 0.5 means we're flipping a fair coin with 50% observing heads, which is equal to 0, and 50% observing tail, which equals to 1. So once we run this command, this R binomial command will generate a vector, and we're going to write the result into this vector A. And so as you see on the screen, it's just a vector with zeros and ones. There are 30 of them here. And then we can calculate the proportion of ones in the sequence, 0.43. So it means we ask computer to flip a coin 30 times, and in 43% of the cases, it turned out to be a head. Okay. Now let's talk about element-wise operations. Here I'm defining vector A, which is just a sequence of numbers from 1 through 10, so 1, 2, 3, 4, 5, all the way to 10. And then if I just type A plus 3, the plus operation will be done element-wise, meaning each element of vector A will be added to 3. So the first, which was 1, becomes 4, 5, all the way to 13. And also we can do element-wise logical operations. So if I say A equals to 5, so A greater than 5, this greater operator will be applied to every element of A. So we'll have a sequence of true and false statements. And of course, first 5 elements of A is not greater than 5. So the logical result will be false. And the rest of them are greater than 5. So we'll have true for those elements. And again, we can combine the sum operation and the logical comparison operation to calculate number of elements in the sequence that are greater than 5. So A greater than 5 will generate a sequence of true and falses. And I will have 5 elements which are true in this sequence and 5 elements which are false. And when I apply sum function, it will count the number of how many true state elements I have in this sequence. So I have 5, meaning that 5 elements in A are greater than 5. Okay, next topic is data frames. Data frame is just a table, like an Excel table. So you have columns and you have rows. And in R, you can use this read.csv command. Read.csv command takes a CSV file. So we can go to the address of this CSV file. So that's how this comma-separated file looks like. It's just rows, and each item in the row is separated by the comma. So let's read this file, and we're gonna use this head command. Head command will print first 6 rows of this table on the screen. So this table has 1, 2, 3, 4, 5 columns, and the first thing that's printed on the screen is going to be the titles of those columns and the names of the columns. And then you will see 1, 2, 3. So those are going to be individual rows in this table. So the first 6 rows in this table will be printed. And so you can see that each row, the first column is the number of the favorite team. This is a Super Bowl data set, which we'll use in one of the homeworks. Favorite team. So in the first game, it was Green Bay. And the underdog in the first game was Kansas City. And the spread is the result that was predicted by the bookies. The difference in the scores is 14, and the actual outcome was 25. So Green Bay won Kansas City by 25 points, while 14 was the prediction in by the bookies. And upset 0 means that the outcome of the game was correctly predicted by the bookies. And another thing that you should you'll be using once in a while is this dollar operator. Dollar operator allows us to pick a specific column from the table. So this Super Bowl table, dollar favorite, will give us the favorite column of the Super Bowl data frame. And then if I say in square brackets 1 through 6, 1 semicolon 6, it will give me only first 6 elements from this column. So it will tell me that in the first 6 games, those were the favorite teams: Green Bay, Baltimore, Minnesota, Dallas, and Dallas again. Another command that's useful to look at the data frames at the tables is this str command. It stands for structure. Structure command tells us what type of columns we have in the data set. So if you apply this command to our Super Bowl data set, you'll see that the first line will tell us how many observations we have, and each row in the table is the observation. And we have 5 variables, means that we have 5 columns in the data set. And then for each of the columns, it will give you the name of the column, then type of the column. CHR stands for character, means it's just a string, it's a sequence of characters. And we have 3 numeric columns: spread, outcome, and upset. Spread and outcome are numeric columns, meaning that those are the numbers that can have decimals, and upset is the integer, meaning that it only can take integer values. In this case, those are zeros and ones. So R, when it uses this read.csv file, it reads the file from the text file, and also tries to interpret the types of each of the columns while it's been read into the memory. And also we can use this summary command, which will calculate summary statistics for each of the columns. And for the first 2 columns, favorite and underdog, it's not a numeric column, so there is no summary statistics to be calculated. So the R will simply say that it's a character column, and that will be it. But for 3 numeric columns, it will give us 6 different summary statistics. So it will give us the minimum value and the maximum value. Then it will give us 2 quantiles. The first quantile means 25th quantile, and the third quantile means 75th quantile. Then it will give us the median and the mean for each of those columns. Now let's look at how we can generate graphics in R. We will use Google Dataset. Google Dataset is just the dataset that contains prices of the Google stock, starting from 2005 and all the way to 2021. So again, I'm gonna read the table that contains the Google prices using this read.csv command. And head will give me the first 6 rows from this data set, and we see that the columns are the date, which is the so that's a daily data set. For each of the days, we have the opening price for the stock, high of the day, low of the day, closing price of the stock, and adjusted close is when we adjust for the splits and dividends. And the volume is how many shares were traded of Google stock on that specific day. Let's try to plot the histogram of the prices. And now you're just going to use the hist function, and then you specify a histogram of what vector you want to use, or for what sequence of numbers. So here we're going to take the Google table, and from the Google table we will take this adjusted close column, and we will plot a histogram of that. And here main will be just the text that appears on the top of the histogram, so you see it here, closing price histogram, and X lab is the label for the x-axis closing price. This is just something to look the plot more readable. So if you look at the histogram, you see that the smallest value is 0, which is obvious, or smallest values are in the range between 0 and 300. So each bar here is associated with an interval of the values. So, and in this table that we have, most of the prices were recorded in this interval somewhere between 300 and 400, and it goes all the way to 2000. So Google stock went to 2000 recently in 2021. So we don't have that many observations at this price point, but most of the times it was around $350, $400 starting from the observations. Now let's look at how to generate a line plot, because usually we want to understand how the price changes over time rather than looking at the histogram of the prices. And for this, again, we're going to take this adjusted close column, but instead of asking to plot a histogram, we'll use this plot command. Plot command is used for scatter plots or for the line plots. And here we specify type equal L, means that we want the line plot, and we can specify the color of the line. We want the red line, and LWD controls the width of the line, and the Y label again, just to make the plot a little bit more readable, we say that it's a price. So now you see that the price of the Google at the beginning of our observation started at around 200, and at the end of the observations went a little bit above 2000. Now what you see here on the x-axis, you see this index label. Index means that's the number of the row in the data frame in the table, which is not very helpful, of course. Instead of using this index, we want to use the dates here. We want to see at the plot of the price versus the date. And before we do this, we have to convert the date column into the date format. If you look at the structure of the Google dataset, so you're going to call this str Google command, you'll see that the first column, the date column, actually is of type character, so it's just a sequence of characters. When R reads in the data frame from the file, it does not understand that this is not just a sequence of characters, but it's a year, month, and day. R just thinks it's a sequence of characters and treats it as such. But we can fix it relatively easy. In R, there is a command which is called sdate. So we say that google.date command need to be rewritten. So instead of using the original google.date command, we're going to apply this sdate, and sdate will convert sequence of characters into the actual time and date format. And now if you, after applying this sdate command, if you look at the structure of the Google dataset, you'll see that the first column date is of type date actually. So now R understands that this is year, month, and day. Now we can generate a prettier plot for the Google price. Now we say that we want to use the date for the x-axis, and for the y we want to use the closing price. And again, we say it's a plot of type L, it's going to be a line. And the label for the x-axis will be date now, and the y label as before is the closing price. So now you see it's a more meaningful plot, Now we can see that the original starting date in our data set was beginning of 2005, and then it went to the end of 2020, or maybe at the beginning of 2021 here, and the price changed somewhere from 200 to 2000 in this time frame, and you can see exactly how the price evolved over the time. And a few miscellaneous things. So whenever you want to get help for a specific command, you just can call help and then type the name of the command in RStudio, and the help file will be printed in one of your panels of RStudio.